so far in this course, we have been talking a lot about what types of analysis on a business process we can do using process mining techniques, assuming that I have the data sitting in front of me. But I mean, it's already quite a lot of work to get the data into the process mining tool in order to be able to do this analysis. We have also been kind of assuming that the business questions that we are answering are already there and have been framed. So for example, might be that I have a performance issue, an issue of too long cycle times or too high costs or very high resource utilization. And the metrics are already in front of me, and I have to just figure out why is it that the resource utilization is very high. So that's the scenarios we have been dealing in the past few sessions. But in reality, I mean, we don't get to have the data and the questions sitting there for just to do it. We have to frame those questions. We have to get the data. We have to do the analysis, and we also have to interpret the results, and we have to translate these results into business process changes that will have an impact in the organization. Even more than that, as part of a process mining team, we are even responsible to make sure that we quantify the benefits of process mining and that we communicate them around so that there is enough traction, enough backing, enough trust in what process mining can do so that we can get our next project down the road. So in this lecture, I am going to be talking about project management and data preparation aspects for process mining. And I put the two together because they go hand in hand. Framing the business question that we want to answer in a process mining project is very tightly related to identifying, extracting, transforming the data that will be required to answer these questions. So these things, project management for process mining and data preparation for process mining, somehow go hand in hand, and it's better to see them as part of the same process. So with respect to the course outline, we are at the moment in a little bit more than the middle of the course. We have already covered quite a lot of techniques for process mining, automated process discovery, performance mining, variant analysis, even what-if process mining. And we are now moving into project management, data preparation aspects for process mining, followed by advanced topics like programmatic process mining, predictive process monitoring, and other trendy topics. So I'm going to introduce today a method for project management for process mining called PM2, which stands for PMPM, Project Management for Process Mining. It is a method that is directly inspired by a broader method for data mining, for project management of data mining projects called CRISP-DM, and which maybe many of you have heard about and even had a look inside. But it is a simplified version of CRISP-DM. I mean, CRISP-DM is a methodology that has like dozens of different tasks and dozens of different deliverables because it has to be generic. It has to be applicable to any data mining project. PM2 is a derivative of CRISP-DM that is much simpler in nature because it's focused on what is typically required in a process mining project. Like CRISP-DM or similar to CRISP-DM, PM2 has a number of phases, in this case, 5 phases. Phase number 1 is problem understanding and framing. Phase number 2 is everything to do with data collection, extraction, transformation, and loading of data. Phase number 3 is the actual analysis. Effectively, all the previous lessons have focused on phase number 3, which is analyzing a given process mining data set, assuming that we already have it loaded in the tool, and also assuming that we have a very good understanding of the problem we want to answer. And then there is phase number 4, which is interpreting the results, which is kind of hands in hand with process analysis, and obviously analyzing and interpreting and communicating is an iterative process. And then phase number 5 is creating impact out of the insights that we derive from process mining. That was the high-level view of the methodology. At a more detailed level, the methodology has a number of people who are involved, also called roles. It has a number of actions or tasks that need to be performed, and it has a certain number of deliverables or outcomes that are obtained as each of these 5 phases. In this slide, I am offering to you a detailed view, a more detailed view of the PM2 methodology that we have designed internally within Apromore, and that tells you like what are the typical tasks that you will find in phase 1, phase 2, phase 3, etc. Who are the typical people, the roles that are involved in each of these phases, and what are the outcomes of each of these phases. I am not going to kind of enter straight away into each of the details of this, as we will see them phase by phase, but just to give you an example of what you will find in this sort of cheat sheet that I am showing to you. I'm gonna try to go, for example, through the first phase. So in the first phase, problem framing, for example, the sheet, this template is telling you that you need to make sure that you identify the main stakeholders. You need to make sure that together with the stakeholders, you identify the project goals. From those project goals, you need to refine and determine what business processes in the organization we need to look into. You have to select some of those processes. For within these processes, you have to identify what are the questions that you would like to answer. So you have to turn your business goals into questions according to a goal question framework. And these questions have to be turned into corresponding performance measures or KPIs. And we have discussed a little bit about different types of performance measures along different dimensions. This type of work is done usually by 3 people: an executive manager, a business analyst. Executive manager is the one who usually will sponsor the project, is the one who has budget and who says, we need to address this particular problem that we're having in this process. Then there is a business process owner. A process owner is a manager in the organization who is responsible for a given business process. So if our project involves improving a process for order to cash, we really need to have the owner of that process, of that O2C process, on board into our project management team. And of course, possibly a business analyst or an expert in process mining who will be able to drive the formulation of the business questions and the identification of the KPIs in such a way that it is realistic to assume that we will be able to answer those questions. The output of this is a sign-off on a project, typically like a description of the business questions, of the KPIs that we will be trying to improve, and a sign-off of that by the executive management so that we can go ahead with the remaining phases of the project. And then we move into data collection, etc. So let me go through each of these phases one by one. In phase number 1, which is called problem framing, as I said before, the first thing you need is to identify who you need to get involved in a given project. It's not, it's very important to stop straight away when you are engaging in a process mining project, and answer that question very carefully. Failure to include certain stakeholders into the project will lead to you having beautiful insights, but not being able to implement them because you do not have buy-in from the right people. So you, as a project manager of a process mining project, you need to think ahead. You need to involve in the project in the early stages, not only, let's say, the person who raised the problem that you are trying to investigate, which might be a subject matter expert. You need to involve the owner of the process. You need to, or a delegate of them, make sure that they are on board, because what is the outcome of process mining is a proposal for a bunch of process changes. And you need to make sure that those changes you are proposing are actually going to be implemented. If they do not get implemented, then the project is going to be effectively unsuccessful. You can propose changes, but if they are not implemented, they are not going to create impact. And next time, you're not going to have credibility to launch another process mining project. You need to make sure, perhaps, if this project has a bit of a broad scope, you have to make sure that you even involve, people at the executive management. So if you are trying to improve the order to cash process, together with the process owner, you have to figure out if you should go and pitch this process at the chief financial officer or at the chief operation officer level, in order to give perhaps, like a bigger, broader kind of a mission to accomplish this project and the resources that you're going to need for that. The second thing is you need to establish the goals of the projects and how it aligns to the strategy of the organization. You need to be able to formulate in about 2 paragraphs maximum, like half a pager, what is the goal of this project? What are you trying to improve? And you need to make sure it aligns with the company strategy. Every company out there defines a strategy and reviews it on a yearly basis. And one year, the strategy might be to improve customer service. So another year, it might be the strategy has an axis on reducing costs or improving resilience or allowing the company to adapt to an ongoing pandemic. So you have to always be very careful that you formulate a goal for your process mining project that rings a bell with respect to the company strategy. And sometimes this means, for good or for bad, that you start with a problem that somebody pointed out and you end up with a slightly different one. For example, I have seen projects being started because customers have been complaining about delays or defects in their order to cash process. However, at the time when the project was started, the company was engaged in cost reductions. And you don't want, in an environment where you are trying to reduce costs, to be on the side of like, we're going to try to improve customer service, and this might mean increasing costs. You cannot do that. You can even have your project shut down if it's not contributing to reducing costs. So you have to say, well, we are going to find inefficiencies that are causing a higher cost and also delays for my customers. So you see how I started from delays for my customers, and I turn it into identifying waste that are causing inefficiencies that will allow us to reduce cost and improve delays for my process. And this is quite common. Many, as when we come from a data science background, we like very much to think that, if we find something wrong in a given system, like in a process, by looking at the data, we have won. But unfortunately, that's not the case. You need to, also make sure that you have the other people in the organization on board. You never win alone in an organization. It's not a cowboy world where, you combat everybody and you win. You have to align yourself with what is important or what is perceived to be important for the company, for the organization, at that particular point in time. Then, once you have defined it, okay, my goal is to reduce delays and defects that customers are experiencing in the delivery of their orders. Once you have formulated that goal, you will try to refine it into some concrete questions that we will try to answer with process mining. And that might be, for example, in an order to cash process, it might be like, I'm going to investigate, I'm going to find out why is it that in some regions we are experiencing more frequent delays in customer deliveries than in other regions? Or why is it that this year we are having more delayed deliveries than we did last year? So you're going to formulate a number of questions that are closer to the ones that you can answer with respect to the original goal. So you took the goal and you refine it. For example, if you are in an insurance claims process and there is customers are complaining about the way their claims are being resolved, then you're going to ask questions about like, what are the differences between cases where the customer complains and cases where they do not complain. So I have turned a goal, which is to improve customer satisfaction with a process, into a set of questions. And those questions, you then need to accompany them or turn them or link them also to KPIs, to performance measures, so that later you can measure if you can really improve your business process. So for example, if you tell me I want to improve customer satisfaction, and that's my goal, as I turn it into questions, I also need to ask myself the question, what KPIs am I trying to improve? For example, you might be trying to improve the percentage of customer complaints or of cases that leads to a customer complaint. Or you might be trying to improve the amount of time that it takes to resolve customer complaints, or you might be trying to improve the customer satisfaction score, the score that customers give you at the end of their complaint resolution. There are slightly different things to improve. So you have to turn things, your goal, into questions and link those questions to performance metrics. There is a beautiful framework called Goal Question Metrics, GQM, which is typically used to do this kind of goal refinement, not only in the field of process mining, but in any other field of business improvement. So then, as data scientists at that point in time, if you are involved as business analysts in this phase of the project, you might also want to formulate certain hypotheses. Why this is important? Because the hypotheses are the intersection between you as a data analyst or data scientist and the business people. The business people actually know a lot about what might be causing delays in a process. They have a lot of domain knowledge. So during the problem framing phase, you might want to formulate certain hypotheses as well, in addition to questions. You might want to say, for example, that the delays in the delivery of orders to customers are caused by performance bottlenecks in the warehouses, caused, for example, by a wrong, inefficient arrangement of the products in the warehouse. So you might want to raise that hypothesis up front and brainstorm it with the people in the warehouse, because they might tell you, no, that's not true, or anyway, even if that were true, we cannot change the way things are arranged because it will affect this and this other process. So you might get, by formulating hypotheses, some initial domain knowledge and directions from the domain experts, from the business experts at this phase. And as you finish with the problem framing, you might want to also agree with the stakeholders, particularly with the process manager, the process owner. What is it that under what conditions they will consider that this project has been successful. So at the bottom of your description of the problem, you might have something called success criteria. Like if we identify at least 3 key sources of inefficiencies in this process that will account for that will allow us to reduce at least 50,000 euros in annual expenses, then would that make the project successful? You ask that question and you try to understand with the stakeholders, what is it that will make them excited about the outputs of this project? It's very important. All of these, you usually try to put in a 1 or 2 pager that has description, like the title of the project, a description of the goals, a description of the questions, performance metrics that you want to improve, possibly some hypotheses you start with and that you wish to validate, and then some success criteria. And you get everybody to agree on this 2-pager at the onset of the project. And of course, it will be revised as the project unfolds, but this initial understanding can save you a lot. So it's great to be iterative. It's great to be agile. I have a problem here. So it is a good thing to be iterative. It is a good thing to be agile, but it's even more powerful when you do an agile project on top of a well-understood foundation, a well-understood, well-framed problem. The more you can do, the more efficient your iterations can be down the road in later phases of the project. Okay, one of the key questions that practitioners encounter at this stage of the problem is the problem facing phase is to understand among possibly multiple projects that I can start, because it's never the case that you will only have one process mining project that can be started at some point in time. There might be several ones, because there might be problems in different processes in the organization. There might be processes in your purchasing process. There might be problems in your order to cash process, in your invoicing process, in your logistics processes. So you might have problems in different parts of the organizations. One of the questions that practitioners often tell us they encounter when they, in this phase of process mining project, is which of these different processes that I have out there should I focus in? In other words, should I really start a project in this direction? Now that I have framed it, is it really a high priority project? Should I really do it? And to answer this question, practice shows that it's important to answer 4 questions. And if you tick on the box on all of them, then yes, you have a high priority project in your hand. You should be investing into it. The first question is, how bad is this process, or how healthy is this process that you are trying to improve? If you ask people around, do they perceive that the order to cash process is functioning well? Do they perceive that customers are responding well? So you ask these questions from different people, including potentially customers, and you try to gauge if there's really the process is broken, and that in such a way that it requires launching a 2 to 3 month project to improve it. The second question you need to ask is this process important? I have been called in to help in process mining projects for organizations. And very often I find myself in a situation sitting on a chair or sitting in a virtual room in a meeting lately, talking to different stakeholders and figuring out, for example, that we want to improve a human resource process that is only executed every 3 to 6 months, and that is kind of not critical for the organization, and then trying to kind of pull myself gently out of it, because I don't want to be involved in a process, in an improvement project that is trying to improve a process that only a handful of people care about, and that is not hurting a lot of people. Obviously, I try to focus on the most important processes out there, the ones that are going to create more business value for the organization. So the importance of the process has to be taken into account. If you are in an organizational setting, make sure you align yourself with the projects and the people that are tackling the most important problems of the organization. And this is just economics, dynamics. It's like, if people focus on what is most important to the organization, then overall the organization will be going better. Feasibility is important. I also find myself in several projects where there are some real problems, but unfortunately, there is resistance to change. Some people will not want this process to be changed. And then when that happens, I also try to sneak out and say no gently, because I don't want to be in a situation where we have spent, say, 100,000 euros on a process mining project lasting 6 months, very extensive analysis, and come up with a bunch of recommendations that will not be followed. That is over-processing waste by all means. So you have to be very careful also that make sure that you are in a project, that this project is going to lead to changes that can be implemented, and to have a very good idea of what changes can be implemented. Maybe to have an idea of, like, for example, if we are gonna, after this project, we are gonna recommend to automate, say, 10 tasks. Is there a budget to do so? Because if there is no budget to do so, you might come up with your beautiful proposal on how to improve this cycle time of this process by threefold by automating 10 tasks, and then bang, you don't have the budget to proceed. You have to be holistic and count on those things as well. And finally, number 4 is, is it possible in a realistic manner to get the data that is required to answer these questions? And I find myself also in many situations where there is a beautiful problem. It's the process, the problem exists, the process is broken. The process is important, like an order to cash process. There is commitment to making changes in this process, so it's feasible to implement changes to this process. But guess what? The data to improve this process is not there. I mean, just like as early as yesterday, I had a situation like that, where I have to pull the plug on something because I say, look, all the conditions are fulfilled, but the data for this process is sitting on some 1988 Fox-based application. Fox-base is an old database desktop application, horrible stuff, horrible legacy systems that is not recording the events that I need in order to do process mining. So I have to be very frank with people. And if I am frank, I get better results down the road in the long term. I have to be very frank and say, we're not going to be, this Fox-based stuff, it's very difficult to extract data from it, and the data is most likely not even there. So maybe let's launch a feasibility study to see if the database is there. Let's not launch the process mining project. Let's just launch a data extraction feasibility mini project where one person will try to see if the data is there. And until we prove that the data is there and I will be able to do process mining with it, I would just say, let's not start this project. And this is very important as well. Many projects will fail because it turns out that the effort required to extract the data was too large compared to the benefits of the improvement project. You need to have a very good idea of how much effort there is. I've also had situations where, for example, there is data sitting in a CRM system called, for example, Salesforce. And in Salesforce, in order to be able to get historical records of the actions that are performed on different CRM, on different types of business objects, you have to turn on a function for logging, meaning by default, Salesforce or Microsoft Dynamics are not logging the actions that are being performed on different objects. And therefore, you can only extract like the latest snapshot of what has happened to a given purchase order, but you cannot extract the whole history out of it until you have turned on that logging function. So very often we go and we say, yes, we have a beautiful problem question, all the ticks on the boxes on this criteria, but to get the data, we first need to turn on logging in Salesforce, come back 3 months later and grab the data of those 3 months in order to do process mining. So it's very important that at the start of the project in phase 1, you set those things in place. The second phase is a very important phase, and I'm going to be focusing a lot on it today, which is data collection. So assuming the data is there, it's never in the format you have seen it in the previous lessons in Apromore. So in a way, in the previous lessons in Apromore that we have had until now, I have been very, I have put you in a very controlled environment. You know, we have given you data sets, you are inside the tool, you have a question, you have some performance metric that you need to investigate, and you start answering questions. In reality, data comes in a much messier manner. So you need to go through a whole process of even one, identifying the data sources from which you can extract event logs to analyze a business process, and then go through a whole procedure of extracting data, transforming the data, and then finally loading it into the tool. Usually the loading part is the simplest one, not necessarily the simplest, technically speaking, but it's the one that is more mechanic. You just bang, you do it. Whereas the ones that take a lot of time are the extraction and to a large extent also the transformation, as we will see, and the identification of data sources. So based on my experience and some experience of others, I offer you a workflow of several steps you might need to go through in order to identify from where you should extract data in order to do process mining. Yeah, the first thing you need to do is think about your process and think, what are the business objects or documents that are manipulated in this process? Usually, they come from the name of the process. So for example, in an order to cash process, the purchase order is an important business object. If you map the process, if you start thinking about the process step by step, you will, at some point in time, you will realize that there are invoices in this process. So I need to find invoices that I send to my suppliers or that I receive from my suppliers. There are payments, so you have to find information about payments. There are deliveries, and when you receive something, you enter some note that you have received it. So delivery receipts, they are called. So you need to grab those business objects that exist in the business process conceptually, and you need to find out by talking to the data stewards and to the data owners in the organization, where can you find information about it? Where are the purchase orders created? Where are they being modified? Where are they being stored? Where are the invoices created, etc.? And then you need to go with the data owners and identify, where can you find this data? Business processes are very complex beasts. So an end-to-end business process for, let's say, order to cash or insurance claims handling might have something like 100 different activities, and the data might be distributed in many different locations. So it's very useful to adopt a divide and conquer approach. So take your order to cash process and decompose it into main phases. For example, there is the phase where the order is received and verified. You get to a point where the order is verified. That thing is called a milestone in the process. After order verification, you do, for example, everything related to receipt of the products, verification of the products, and routing the products to the correct place in the organization. That's called receipt. So that's another phase of the process that leads to the products arriving to the correct person in the organization. The third phase might be everything to do with between the moment I receive an invoice and the moment I pay it. So that's everything to do with the invoicing phase. And you try to set yourself goals for each of these three phases. I'm going to extract data for this phase, for that phase, and for that phase. And maybe you will do it sequentially, or maybe you will do it in parallel, depending on how many resources you have in your project, how many data engineers you have helping you with this data extraction process. The next thing you need to do is, between two milestones, between the moment I receive an order, sorry for that, between the moment I receive an order and the moment I have verified the order, what are the activities in this process? You need to have like a list of main activities that you perform. That knowing those activities is going to help you a lot to determine, do I have the data? Are these activities being recorded where they are recorded? Knowing the names of the activities that you want to extract helps you guide your conversations with the data engineers, the data stewards that have access to those databases. It's good. You go milestones, within two milestones, you map what activities there are, you come up with a list of such activities, and you go and talk to the data stewards to find out in which database tables of which system can we find that, that data about when were those activities executed for a given purchase order. Then you, through these conversations you will have with the data stewards, the data owners, you will drill down and you will say, here are the tables where my data is located, and you'll be able to do a bit of a select star on those tables and say, oh God, here's the data. Now we need to extract it, and we need to make sure that we can relate multiple tables together. So you need to have a good idea of where are the foreign keys and the primary keys that will allow you, for example, to join data about your customers, like the customer addresses, names, shipping addresses, etc. How can you join that with the data about the purchase orders that you have received from your customers, and how this purchase order have been shipped, etc. So you need to have a very good understanding of how to connect these different tables. That's the next phase, identifying the tables and their relationships. So in a way, understanding the subset of the data model that from where you're going to extract data. Then you will typically want to start thinking about, like, let me imagine that I will join all these tables into a single one. Remember, an event log is a data frame in non-first normal form. So it's like you take multiple tables and you join them. You think about your big log, with where every row is one event, like a purchase order, and there is like the timestamp, the case ID, the activity, and possibly like 20, 30, 40 attributes. So you think about it that way, and you start thinking about which of those attributes are case attributes. They tell you something about a case. They do not change during the execution of the case, versus event attributes. And remember, event attributes are those attributes whose value can change. For example, the delivered amount in a purchase order can change. Initially, you might receive 50 units of your product, then another 50, then another 100. So the number of delivered products can be changing as the process gets executed. So that is an event attribute. So you get a very clear idea, like in a way of how the log will look like if you had to manually import it into the process mining tool, as we have been doing in this course. And then, of course, you have to extract the data. So which means that once you have identified the tables and the relationships, the joins that you have to do, the columns you want to retain, the ones you want to drop out, you need to then write a number of SQL queries and then wrap them around some script that will do all the extraction. Well, obviously, you don't always have to do this process from scratch. There are every process mining tool, like a Promore, will have, if you ask the vendor, a number of pre-built adapters. So a Promore, for example, has an adapter for extracting data from SAP. So then, you can just configure the adapter, say, I want this and this and these tables from SAP for this and this business process, and it will automatically produce the queries that are required to be executed on the subsystem, on the sub-database, in order to move them into the process mining tool. So it's not like you have to answer all these questions from scratch for every process mining project, but in every process mining project, there is a bit of these questions out there, because even if you run your order to cash process in an ERP system like SAP, there might be some steps in the process for which the data is not in the SAP system, but in some other system. So you still have to do some of the analysis that is listed here. And if you are going to do this type of analysis for an industry-specific process, like a banking process, or like a foreign exchange process in a bank, for example, or for a pharmaceutical, for example, clinical trials type of process, you will probably they will probably not be using a standardized system like SAP or Salesforce, etc. They will be using like custom-made systems or very specialized systems, and you will have to go through all these exercises. Of course, you then extract that, and you think you are done. You extract the data, you have a data frame that resembles an event log, and you will think you are done, and unfortunately you are not. And to illustrate what are the issues, I'm going to show you like a concrete example. I'm going to exit the presentation for a minute to show you this concretely. Discard the annotations. And I'm going to bring in an Excel table. This is an event log. I'll try to maybe make it a little bit larger, zoom to maybe 200% if I can. Okay. This is an event log extracted from a system that records travels, business trips executed at some university in the Netherlands. Of course, it has been anonymized, but it's actually real data at the beginning. So there are staff members. Somewhere you can find some pseudo identifier for them who create declarations. And this is a table that was extracted from that system. It's in CSV format, a table extracted with the system where you find information of different international travel declarations. It's an international travel declaration is a form or a permit request. It's a form that the staff member submits in order to get an international travel approved before undertaking the travel. So they fill in a declaration. They link it to some budget. Sometimes this declaration is linked to some other declarations. There's the origin and the destination and all sorts of columns that you would expect to find in such a place. This is a declaration of these are the declarations that the staff members fill in once they have completed a travel and they want to claim reimbursements back for their business costs during the travel. So they fill in a cost declaration, is called, and they say, I spent this amount of money during this particular travel, and in order to pay, for example, for the hotel, or to pay for a taxi cab, or to pay for some a dinner or whatever. So they fill in these declarations and they write all their expenses. The declaration goes through a number of steps, and that's why you have multiple events per declaration. So this is everything that happened to declaration number 7457. There are 6 steps. The trip was started. the permit was submitted, the declaration was submitted, the payment was requested, and the payment was made. So this is the whole history of that cost declaration. This cost declaration actually does not contain information about where the employee traveled, on which dates they actually travel, who approved, etc. That information is not in this table. So there is another table extracted from another part of that system called the permitting table. Every event in here, there is a reference to a travel permit. Here we only know that this person asked for a certain reimbursement of 39 euros or something like that, but we don't know in the context of what trip it was, who approved this trip, when was this trip made. That information is in another table and is linked via travel permit. I'm gonna try to open the foreign permit. So, okay, for every, here in this table, for every travel permit, you see when was it completed, what activities were performed to approve that, and from where the budget comes, possibly some, and then it's also linked through the declaration numbers that have happened to this case. So if I want to get the end-to-end view of a business trip, so if I want to see the whole process from the moment you put you lodge a permission, a request to travel, to the moment you complete the travel and you have reimbursed, I have to kind of take two tables and I have to join them, and I have to join the corresponding events so that I can get the full picture of, like, okay, you got the approval for the permit, or maybe you got initially declined and then you revised it and then you got it approved and it's linked to a certain budget. And then later you traveled and you came back and you made, let's say, 2 cost declarations and you got 2 reimbursements. If I want to see the end-to-end process, I will need to join these 2 different tables. And in some cases, you even have to join 3 different tables. So once you have extracted the data, you still have to do a lot of, like, joining it to get the end-to-end view, and then dealing with a number of issues that you will, the typical data quality issues. In the field of process mining, there are a number of data quality issues. There are 3 that are very recurrent. There are issues that have to do with the case identifier. There are issues that have to do with the timestamps, and there are issues that have to do with the activities. Those are the 3 compulsory elements in an event log. So naturally, data quality issues get divided typically into those 3. And then there is a number of other issues. Let me examine first the case ID issues that you might encounter in real life. So there are some very, very nasty cases where you have an event log where there is actually no identifier of the process, no case identifier. So for example, if you, in a hospital information system, it's very often the case that you want to analyze the treatment of a patient. Let's say that I am treating a patient for a possible disease, say a stomach disease, but I don't. I have a lot of information about what has been done to this patient, but I cannot separate steps that have been performed because of the stomach problem from other steps that have been performed because of some other problem that the customer has, like, for example, some liver disease. All these events are mixed up. The only identifier I have next to each event is the patient ID, but the patient might have undergone multiple treatments in parallel at the same time. So it's not very easy to separate them. If they are sequential, okay, you can say, like, this period of time, in this period of time, this customer was being treated for this, and in that period of time, they were being treated for that. But sometimes they are kind of in parallel. So end game is that very often you have a process in your mind, but you don't have in your database a column that will talk about one instance of that process, like a treatment ID or a disease ID or a diagnosis ID. All you have is patient IDs. And in this setting, a patient ID is a quasi-identifier. It happens very often also if you take event logs from an e-commerce shop, or worst, from a customer journey shop. Let's say that I run a web portal and people come to look for information and they hit the web portal and they come and they do some queries and they look for some information and they find it. If I wanted to analyze that customer process, one of the problems I will have is that usually in my database, I don't have like a session, a web session ID. I know for every time my database was hit, I know which customer was hit it. So I have some customer ID in the best case, but I don't have like a session ID. So you have to go through a procedure of so-called sessionization, which means you take all the events that happen to each customer, you take the events of one customer, and you try to temporally split them up to create multiple case IDs, in this case, multiple sessions per customer. For example, you might say, well, if a customer came yesterday and stayed for 2 hours and then left, and then in the night they came back and they stayed for another 2 hours in my website, then I will consider that these are 2 sessions because there is a period of inactivity in between of more than 1 hour, for example. So that's how you can take all the events of a given customer and split them into sessions. And you could do the same in the hospital information systems case for this patient who might have undergone multiple diseases. You might say, okay, I'm going to take the data of all the events of a patient, and I'm going to say that if a patient underwent some activities and then there was a break of more than 3 days, then whatever happened afterwards is not the same treatment, it's a different treatment. So I can make those kind of choices to approximate the case ID that I am lacking. That's a very frequent type of scenarios. There is no general answer to how do I do that. I see a lot of people asking how I do that. I says, well, there's no answer to that question. There's just a number of situations and patterns of how you can deal with it, but then you have to look case by case and resolve them depending on your particular project. Very often, that's another recurrent situation. You don't have one case identifier, but multiple ones. I just try to show you in Excel an example of that, where there is a process where someone requests a permit to travel, and later when they come back, they fill in a cost declaration to get reimbursed for their travel expenses. And that is another scenario. I think I'm having, the video went off. That is another scenario that you will frequently encounter, is that there is no one case identifier, but multiple ones. One for the permit, travel permit, and another one for the cost declaration. When that happens, they cover different phases of the product, of the process. One is the permit, the part of the process where you get permission to travel, and the other one is when you get reimbursed. And you have to hunt for that table in your database that has both the permit ID and the cost declaration. And then that table will allow you to find the correspondence between these 2 case IDs, which are case IDs of different sub-processes of the end-to-end process that you want to analyze. And that's why when we prepare event logs for process mining, we're going to do a lot of joining, because naturally the data for different phases in my process is going to be in different databases. And if I am lucky, there will be a database that allows me to join the 2. It's the same in an order to cash process. You will find data about the purchase order on one side and data about the invoices on another side. And if you want to get the whole process, you have to join these 2 tables. hopefully you will find a table in your database that has a correspondence from invoice ID to purchase order ID, which will allow you to make this correspondence between the invoices and the purchase orders, and therefore reconstruct your whole end-to-end process. There is a whole set of other issues that arise if you move now to the timestamp. You will hope that it's always possible to go to a database and find for every activity that was performed, when was it performed at the granularity of the millisecond. That happens, fortunately, quite often in relative terms, but not always. Very often, I have seen situations where the time of when something happened is not recorded, only the date. We only know the day, we just don't have the time. And that is very, very nasty, because process mining tools use the timestamp in order to determine whether activity A comes before B or B comes before A. And that has a tremendous effect on the process maps and the BPMN models that get drawn. If I have only the timestamp at the level of the day, all the events that happen in a given day, are messed out together, and the tool doesn't know which one came before which. So what can you do? Sometimes what we do is that we start adding like a sequential number. So you say like emergency room registration, we know it happens before emergency room triage. So next to the timestamp, which is at the granularity of the day in this case, we put a sequential number to say this event has order number 1, and that event has order number 2, and the other one has order number 3. And then we can concatenate the timestamp at the level of the day with the timestamp of the order to construct like an artificial timestamp that then allows the tool to order these different events between each other. You will lose some information by doing that, like some durations can no longer be computed, but at least you will have a way of visualizing how the process is executed. Sometimes there are, for some events, you have the granularity at the level of the day, and for others, you have it at the level of the hour. That's also very, very nasty. The only thing that I can suggest is try to move the higher level granularity to the lower level one, either by mapping it to the, let's say, to the hour 000001 or 000000, and then try to see if you can, with some domain knowledge about the order in which activities normally happen, try to put the timestamps in such a way that they follow, the events follow each other in the order you would expect them. But there's not much more to do other than going and changing the system to log at the granularity of the millisecond. So those leads me to a number of so-called timestamp repair tricks that you can apply that can mitigate the problem of timestamps that are at a too coarse-grained of level of granularity, but it doesn't remove the problem. If in some cases you have to abandon and you have to say, we simply do not have the data to be able to analyze this process because the timestamps are at a too high level of granularity. We now need to change the system to do that. And I have seen situations where, we were going to engage in a process mining project and we were sitting at the desk very excited to do it. And then this problem arose. And then we wanted to keep going and we wanted to do the process mining project. And fortunately, we didn't. And we just said, okay, we need to change the system to store the timestamp at the level of the millisecond. And you know what? We came back 6 months later, and the improvement of the process, of that process, which was a patient treatment process, had become a very pressing problem. So we had executive sponsorship, and we had very clear goals and very clear questions, and people were very engaged, and we had the timestamp at the granularity of the millisecond, just because we put that aside for 6 months, and the system was changed meantime so that we could get these things. So sometimes giving up because of the unavailability of data is better than trying to push through artificially through a process mining project with the wrong data, which will not allow you to make conclusions that are sufficiently reliable to promote certain changes in the process. Sometimes, of course, having both start timestamp and end timestamp for every activity is the nirvana, but very often it is not there. Even if you look at major ERP systems like SAP, ServiceNow, etc., they only record the end timestamps and not the start timestamps. So we need to make it up. So here is one recommendation I sometimes do. So I cannot recover stuff that is not there, but I can try to simulate it. So I will say, like, let us take your start timestamp and let us gather information, possibly through observation, about how much time on average every activity takes. And then we fill in an artificial, if we have the end timestamp, we artificially fill in a start timestamp column equals to the end timestamp minus a random number with the average execution time that you found by interviewing people, and a certain distribution, a normal distribution or an exponential, negative exponential distribution. And that way you can artificially simulate or fill in the missing start timestamp. And then, you know, your models look a little bit nicer. You have start and end timestamps. Bear in mind that these are all approximations, but you can maybe do a little bit more analysis and get better pictures of your process in that way. One little issue sometimes is that you only know the start of a task, but not the end. That's actually quite equivalent to only knowing the end and not the start. Anyway, when we manipulate one single timestamp, it just means that we are treating every activity as instantaneous. It happened at one point in time. It doesn't really matter if that was the start timestamp or the end timestamp. You can make pretty much the same conclusions. Just have to reinterpret the process map differently. If you move to the next column in an event log, which is the activity column, there is a whole bunch of data quality issues that arise there. Maybe these are the more tractable ones. Let's say if you have problems with case IDs, that's very bad. If you have problems with timestamps, sometimes it's manageable, sometimes it's nasty. You cannot do anything. Problems with activity labeling are usually quite tractable. You know, it can be, for example, that your activities are at a too low level of granularity. For example, I have been in projects where the activities are URLs. Customers come into the website, tap into some URL, and the URL gets recorded. URLs are very low-level objects, right? So you need to trim them off, extract the relative URL, and then you get too much detail, because I mean you get stuff like the customer click here, the customer click there, the customer click there to place a purchase order, for example. That's too low level of granularity. But either you build manually a table like this activity corresponds to these URLs, this activity corresponds to these relative URLs, etc. You can construct that with the domain experts, or else you can apply some sort of clustering technique on top of the URLs based on the relative times when they occur in a case, or based on their string edit distance of the relative URLs. And you can maybe from there identify a grouping of low-level activities into higher-level activities that is more meaningful to end users. Because, of course, you want that the labels that are displayed on your process maps are meaningful to business users. That's the whole purpose of it. There, I have also seen some more trivial problems. Like, for example, I once had an event log that had 50,000 activities plus. And I say, what? How can you have 50,000 activities in a process? But then when you inspected, it was just that there were activities called order product number 345, order product number 747, etc. For every type of product, there was a different ordering activity for ordering, for placing a purchase order for that product. And of course, just by trimming off, then you get more or less what you want in terms of your activity labels. At this stage, you should also be looking for activities that are not very relevant. For example, we have seen this sepsis event log from a hospital in the Netherlands. And in that sepsis event log, there is an activity called return ER, return to the emergency room, which is kind of not very relevant when you want to analyze the process from intake to release of the patient. It kind of happens like a couple of months later on average. So you probably want to remove those activities. So once you have all your activities in place, think about like, do you really want to include them all in the event log? Or maybe you want to scope the event log to a subset of the activities and remove the others so that you can do a more focused type of process analysis. There are other event log issues that are important, less nasty. Of course, incomplete cases is something we have seen in several previous lectures where you have an activity that should not be the end activity, but you can see a little dotted arc from it to the end, which means that sometimes this activity is the last activity in the case. That signals that you have some incomplete cases. To solve this problem, you need to have a very good idea of which activities should be the ones that occur at the end of a trace. And then you need to apply a filter to only retain those cases where the last activity is an activity that you will expect to be a final activity. Like, for example, closing an order, archiving an order, are activities you will expect there to be at the end. So that requires just defining some filters, and we have seen some practical scenarios of that in previous lessons. There are some events that are very infrequent. You might want to consider removing it. Maybe they don't have any impact on the process, so you can filter them out. There are some situations where the process has changed over time. In that case, you might want to identify the point in time when the process has changed and split your log into two logs, one before the process changed and another one after the process changed. This thing where the process changes, like for example, like a new system was introduced and the business process completely changed, that thing is called concept drift in the field of data mining and process mining in particular. So you have to identify drifts and separate the event log into two accordingly. And of course, sometimes you have a lot of missing values, null values, etc. Fortunately, process mining tools like Apromore are pretty good at handling null values. It's like it's ingrained in the design of the tool. Event attributes in particular are assumed to have null values by default by the tool, because very often when you start an instance of the process, some of the event attributes do not have any value. But still, you need to be on the watch for these situations of missing values that should be there but are not there. It occurs when you least expect it. I just yesterday had a situation with an event log where one of the columns was an SLA column, which tells me in how many minutes should the process complete. And it turns out that about 10% of the process instances were lacking this SLA, so you will not be able to know whether or not those instances have fulfilled their SLA or not fulfilled their SLA, because the SLA information, the deadline for completing the case was missing in the data. In addition to checking and resolving for data quality issues during the transform step of ETL for event log extraction, transformation, and load, you need to also think about two other things. Should you enhance your event log with additional attributes? Very often you want to analyze the cost of executing different activities, and the cost often is equal to the processing time, the difference between end timestamp and start timestamp, multiplied times the unit cost of your resource, how much one person hour takes you. So you might want to add it to your event log, what we call the resource cost, the unit, the cost of a resource per hour, because that will allow you to do cost analysis in your dashboards. Or you might want to add some attributes about like in how many minutes should a process instance complete. That's very useful if you want to reason in terms of violations to SLA. So during the transformation phase, you can think about how can you add those columns by injecting domain knowledge into your data. And finally, in the case where your event log contains private information, particularly in the context of customer-facing processes, where you are talking about data that has been generated by activity of end customers, you are dealing with private information or personally identifiable information, and you need to make sure that you take appropriate measures to handle it. As a minimum, you need to apply what we call data masking techniques to those activities. And in addition, only make them available to the analysts that need to have access to. So it has to be that that data is only being analyzed for the purpose for which it was collected. You need to make sure that you have appropriate consent as well from the customers to be able to analyze their data using process mining. It's a very, very serious thing in light of GDPR. There are various techniques for anonymizing event logs to varying degrees of strength, like, for example, K-anonymity, and there are tools like, for example, ARX, ARX, that will allow you to take a data frame like an event log and anonymize it in order to fulfill, to some extent, anonymization requirements when it happens that you do not have consent to analyze this data for process improvement. The third phase in the PM2 methodology is the process analysis methodology, is the process analysis phase. I am not going to say a lot today about that because it's exactly what we had seen in the previous lessons. You know, how do you, now that I have the event log loaded into a tool, how do I use it to answer different questions? We saw in the previous weeks this workflow where you start with automated process discovery techniques, and then you fork out into conformance checking and performance mining techniques, and then you generate hypotheses that you try to validate using variant analysis techniques. Depending on what your project is about, I mentioned, it might be more about enhancing efficiency or customer experience or enhancing compliance or agility. You will use different combinations of techniques, as we have discussed extensively in the past few weeks. The fourth phase of PM2 is results interpretation and validation. This is a phase where you need to engage back your business users. In fact, you should always have them engaged throughout, but this is another phase where their active involvement is necessary, where you have found some, made some observations on the data, and you start that might answer the questions that you originally posed, and you start bouncing back these observations with them in order to identify which ones are relevant from a business perspective and could lead to actionable changes to the process, and which ones might not be relevant or might be explained by some external factors that are not in the data. So you have some conversations about this with your business stakeholders. You narrow down a set of hypotheses that you have derived from your analysis and initial discussions. Like, for example, one hypothesis could be that the fact that delivery delays of more than 2 days increase the probability of customer complaints by more than 50%. And once you have come up with this very concrete hypothesis, you can go back to the data and use statistical hypothesis testing or causal inference techniques in order to validate those hypotheses, and before you then use them to propose changes to your business process and to launch a project to implement those changes and to improve your process according to the metrics that you had initially were initially tasked to improve. To illustrate how this works in a real case scenario, I will just walk you quickly through a case study that was a very early case study of the application of process mining in a large insurance group in Australia called Suncorp. So Suncorp is a company that does insurance of all types: commercial insurance, motor vehicle insurance, travel insurance, personal insurance, etc. And they have grown to being the largest Australian insurance group, mainly by acquiring other insurance companies. And over time, that has created a lot of heterogeneity in their processes. So the claims handling process is a hybrid of multiple claims handling process, and that leads to certain problems. At some point in time, a project was launched because there were too many claims that were taking longer to resolve than what the SLA dictated. So the SLA was that certain types of claims should be resolved in less than 5 days or 6 days, and then many of them were violating that SLA. So a team consisting of a business analyst, a data engineer, executive manager, and a data scientist were put in place to investigate and tackle this problem for a period of 3 to 4 months. And based on data extracted from an insurance claims handling system, it's actually a insurance policy management system called Guidewire. Fortunately, it's one of the systems where it's quite very well structured, and it's quite easy to find the tables that allows you to trace down how a given insurance claim goes from the moment it is lodged by the customer to the moment it has been resolved and the payment has been made to the customer. This team came up with a formulation of the problem and a very striking illustration of it, whereby they classify claims into simple claims and complex claims. Simple claims should be resolved in less than a certain amount of time. That is the vertical line in this diagram. And the horizontal line in this diagram is the number of days where those claims should have been resolved. The red dots, every red dot corresponds to a simple claim that was not resolved in the time allotted to it, that meaning we violated the SLA, and the green dots are the ones where the claim was resolved in less than the time stipulated by the SLA. So green dots are the good ones, red dots are the bad ones. And of course, this shows you that pretty much a little bit more than 50% of the claims that should have been finished in less than 5 days were not being finished in 5 days. So then the goal here became one of understanding what caused that some claims were going bad in terms of SLA. And initially, this was done by extracting the data from Guidewire and building process maps of the slow, simple claims and the fast, simple claims, the ones that finish on time, the ones that finish late, and then doing sessions of just at different levels of abstraction, walking through every task, every edge in those process maps, comparing them and spotting what were the most striking differences between the two. You do that and you usually end up with around 30 to 50 observations of possible reasons why some claims are taking too long. And then you go to you then drill down and you find that there are some repetitions, some rework that is being observed very frequently in the claims that run late, and that is not being observed in the claims that are completed on time. So the team then identified 4 repetitions of different parts of the process that were much more frequent, or that when these repetitions occurred, the probability of the SLA violation increased significantly, or the frequency of SLA violations increased significantly. And right. And then they trace it down together with the business analyst during the interpretation phase that there were about 3 changes that would be required in order to avoid this rework. So some work instructions needed to be changed. Some data needed to be collected earlier in the process. And when that is done, then the rework does not occur. They changed those work instructions. They did some additional changes also to improve the efficiency of the process based on the observations. And that led to a reduction of the cycle time of this process, the mean cycle time, from almost like 4 weeks to less than a week, and much less than a week, like 3 days, and the ability to fulfill the SLA in the vast majority of the cases. So this is pretty much how a successful process mining project will look like, in a relatively short duration of around 3 to 4 months. So that covers the content I wanted to give you today. So if you have any questions. Okay. Let me check Slack just to make sure that I'm not missing anything. Oh, my Slack is stuck. Well, on Zoom, I don't see any questions. So, okay. So I assume that everything today is pretty clear. So a lot is basically putting together a lot of common sense ideas on how process mining project can be conducted, all the way from problem framing and data preparation to the interpretation and impact that you can make out of the project. So tomorrow, 10:15, Manuel Camargo will be with you to start working hands-on on the topic of data preparation, and you will have 2 weeks about it, this week and next week. I will just announce that next week there will be no lecture. Instead, next week is about introducing you to a process mining library called PM4Py, which is a process mining library for Python. And instead of me giving the lecture, I will distribute to you a couple of video tutorials from the authors of process mining for Python themselves that gives you an introduction of what you can do with PM4Py, with some hands-on demo of how to do it. And that will be a very good preparation for you to do the lab session on PM4Py next Wednesday. So next week, you will see it on Slack. I will write it there. No lecture at this time. Instead, you will have to watch on your own these PM4Py videos. And I will see you in the lecture in 2 weeks' time, when we will start with the topic of predictive process monitoring.